Okay, good morning, everybody. We would like to welcome you to our webinar, Predictive Quality, Digitalization in Automation. It's a pleasure to share this topic with you, the trend towards batch size 1, ever higher quality requirements, and ever increasing level of automation and speed in your production. These are all challenges that you have to face every day in your production. We would like to show you how you can improve your product and process quality with data-driven predictions. My name is Jessica Rominger. I'm the marketing manager at Baumer Inspection. I will be responsible today as your moderator of this webinar. Our general manager, Mr. Bickert, will guide you through our webinar.
Hello together.
The presentation will take about 30 minutes, after which we will answer your questions. I will be available during the webinar in the chat. For technical questions, I can help you directly. If you have individual questions, please feel free to make an appointment with Mr. Schröder. You will find the contact details at the end of the presentation. In order to guarantee an undisturbed course of events, your microphones and cameras are switched off. Personal information will not be displayed in the chat. You can ask your questions anonymously. The webinar will be recorded for internal purpose. So now enjoy the presentation with Mr. Bickert.
Hello, everybody, also from my side. Thank you, Jessica, for the nice introduction. Today, I would like to talk about predictive quality in automation. So, my name is Stefan Bickert. I'm the managing director. Feel free to contact me afterwards. So I would be happy to answer your questions directly after this short talk or via email. The presentation will target mainly 4 questions. So the first point is, what are the reasons of deviations in the production which lead to different quality? What causes deviation in the production? Then other is, where do the costs of poor quality arise from? I would like to stress this a little bit. With the knowledge of them, we can discuss optimization, what will reduce rejects and rework. So how can we optimize the process, and how can we realize the potential from the generated data? That are the 4 questions we will talk about. Let me start with only 3 challenges we often faced with. So nowadays, agility production, that is one of the changes we have to face. So the trend is towards much smaller batch sizes. We see that in the flooring, that's the batch sizes will be reduced. We see that also in the furniture production. There we are going up to the batch size number 1. We see that also in the short cycle press production. There the batch sizes are much shorter. So I think, especially in the furniture industry, we also will have in the future, in the very near future, different distribution channels. I see it right now, even in Germany, and I guess in other countries too. A lot of furniture will be directly from the end customer bought by the factory via internet. So that is and to do that, we need also a very agile production. flexibility and agility in the manufacturing is possible. I will show later on a production where that is possible, but will face the requirements in regard of the quality are the same. So there to do that, to be agile in the production, it is the same quality requirements as in other productions. A next very challenging field is the human factor in our production. So it is in a running production, we will have it is more and more difficult to have the right people there. They are only a few, let's call it reliable employees will drive the production. The experts are not longer on the job floor. Then if you have, let's say, in between of 1 to 4 shifts, if to train the people, especially in inspect manually the production, it's really hard to get the same results if you have such a human factor in. So, and beside the inspection, you can see on the left side a very modern production. The automation is higher and higher. So the beside the product, you need to look to your automation and let them run. That is important. Of course, the pressure in terms of time or in terms of costs, in terms of quality is exactly the same. It's not less, even if you have a production time saving. It's often used word, but can we really save time? So the employees, the recruitment is especially in every country very difficult. I see that in Germany, I see it in China, I see it all over the world. To get the right people is a challenging target. The third challenge we have is the data. Data is the one, and now the important thing is how can we generate information out of the data. In former times, we had let me call it traditional data. That means you have a single sensor, and sensor give you a temperature, give you a pressure, give you time, give you a single answer. But to combine that all and bring that together and get out of a single data, temperature, pressure, and time, get the right information out is the, let's say, for example, the pressing process. Did he work correctly for this special product and this special structure, for example? That is important. The volume of the data is rising a lot, and now make the right decisions, based on data, get information. That is an important thing. And of course, how can you then generate the right KPIs, get the right feedback immediately to control the processes and do immediately the optimization of the processes. That is an big point, and a modern system can support you a lot. Our scanner systems generate digital data and also generate, based on that, the information. Okay, with this in mind, if we would like to go to the objectives, what would we like to do is data-driven predictions to improve the process. The process is running perfectly over a certain time, and even only if anything happen, we would like to control it as fast as possible. We divide that in 4 different items. That is the C principle, what happened in the think, in the act, and in the prevent. That means in the C, we recognize what happened. Is this a sporadic deviation, or is it a process-related defect, for example? It's different. You have to react different. You have to analyze it, of course. Why did it happen? For example, if you could classify the defects in regard to the process step, you know exactly where to go to change the parameters. The act is then what will happen. So if you know that, you can do the optimization. And of course, with the knowledge of the see, think, and act, you can also perspective react what you have measured, and then you can preventively take preventively actions. So that is the goal what we would like to do. Let me shortly discuss about the initial situation of modern manufacturing. So I mentioned it already, the sensor data, they are available, but you need really to know what happened, and you need the complete process, and you need the complete structure to get the right information out of the single sensor and control and make the right conclusions in regard to quality production. A single point will not give you the right answer what will happen with your product. That is one difficulty we have to deal with. The next is with manual control, the individual quality, the assessment lead to real differences. In the end, you would like to have seamless quality. It should not dependent on a individual decision, and only with data you have which are comparable, you can lead that. If the one guy decide different to the other, what will that say in the end in regard to your quality? The next situation where we are in is the requirements of data analysis. You will do that typically from a different point of view. So if you are the user which is running the production right now, he has a totally different view to the current production than, for example, the production manager. He is maybe responsible for the complete production, maybe not only for one line, maybe for more than one line. The quality manager, he's in close interaction with the end customer, and he has a different point to the data, and then, for example, maybe the service has. The service can also get information out of a deviation. What happened? What should he do as a next step? And therefore, a modern system has to give you the right answer to the question you're asking to that. And that is dependent on who you are. Are you the manager, or are you a service person? So, and the the last point here is the operators need a clear instruction. That means if you have qualified people, but maybe not the experts, and then you have to bring all the information up to a level where they get only a recipe. Let's call it a recipe. What to do next if the one thing happened? What has he to do? And sometimes that is in a conflict to the operator's targets he has. For example, if he has a piecework rate, then he is of course interested maybe not to control too sharp, then otherwise his personal income will be influenced. That are things we saw happen Okay, here is one example of an lot size one manufacturing. As you can see, have the plates, the sawings. You have here the edge banding. Could have here a surface inspection. The edge banding, excuse me, is right over here. Go here to the drilling, and here you store that. That is one layout we find very often in such a lot size one production. And of course, we provide different products for different situations. It is starting from the raw board, from the chip board, MDF, MFC. We do embossing in register. We have surface inspection. For the furniture industry, it doesn't matter whether it is foil wrapped, melamine coated, painted, and so on. Then we look to the edge banding. Then we have in the furniture industry a 360 360-degree inspection. We check all the drill holes, of course, even in batch size number one. It's also very important. And of course, we have also products for the flooring industry. But I guess most of you know these products. So we are in the complete value chain. We implement our scanners. And here are typical defects. Some of you know these all, but the question is right now, you as an expert, we know these defects, but do we also know where these defects come from and what we can do if such things happen? And how often happen such defects? And what can we do? Here are surface defects, edge chipping. Maybe the grinder is not working correctly, and you have to tell that the service immediately to change this. We have that also in the surface and inspection, of course, different defects, and with the knowledge of the defects, most of the time what you have to do to react to avoid that defect once again. Of course, we have here sporadic defects will happen maybe only once, but also you can also have if you have a dent in anything in your production, maybe you create a serial defect. So with these defects and the knowledge and the classification, you may know exactly what to do, and that is what you have to tell the operator. Because I don't know exactly who is participating today in my webinar, I would like give you just an 3 or 4 example what a human perception is and what a system can see. You know, only on some examples. It is of course always more impressive if you have the product in front of you, but as you can see, here we have a surface defect. It's really hard. Now we look into that maybe 10 seconds, and I'm not sure whether or not you could find the defect already. Even here, if you can see the arrow, it must be any in this area. But will that defect decide right now? Will that defect lead to a reject, or can you accept that? That is what your operator is typically sees when he look to that. And he, once again, he has maybe less than 10 seconds to decide. Of course, here we have a fold wrapping, so our automatic optical inspection, AOE. As you can see, you have here this wrapped foils, and of course that lead to an reject. Maybe you have to go back into your process and change it to avoid that. Come back to what we see here, an open open edge, or no, that is an open foil. Yeah, also this is from the quality handbook of our customer. It's too much, so that also lead to a reject. Because here you see more or less the same colors, it's really hard to decide it immediately product by product. Or last example, human perception. So it's easy. Here we see a scratch on a dark board. Especially dark boards is hard for optical inspection, but also hard for the human. What we see here, the defect is not this one. That is easy, and white stripe and white scratch on a dark board. The defect is in this area, and we have here a technology to be independent of the feeding direction, and we are independent whether the here in this case it was in scratch, whether the defect is in the direction in the production direction or crosswise to that, or if it is diagonal. We are independent from decor as well as from structure of the board. So, and this is really hard, you know, if that is an serial defect, to see that really, it's hard for human eyes. Okay, but predictive quality, where do the costs of poor product quality arise? Let's shortly talk about after the reasons about the costs. So, of course, we know all, if you have reject, if you have a reject, that will that is what we would like to avoid. So, with an immediate process optimization, you can avoid a lot of these rejects. You know, even if your user is well trained, but you can give him a recipe what to do if anything happened. Of course, in lot size, especially in lot size number 1 production, you have to go back. If you have a reject, you have to go back and do the rework. And that, of course, yeah, the utilization of the machine, you know, what your production capacity is. If you have to do the rework, of course, reduce also this issue. Of course, material saving, or if you produce and reject, material saving is also an issue. It's also a factor. Utilization with predictive maintenance, for example, and defect classes, you can much better do, for example, maintenance. Predictive maintenance is nowadays a things you have to do. I guess the most of you have done strategies to do that internally. And yeah, the human factor, system support of system of operators, that is more and more important to support them with expert knowledge. Put that into a system instead into each operator. Of course, costs also driven by suppliers. If the supplier deliver not what you expected and what you pay for, we have customers which are using these systems to start at least a discussion with their suppliers. And of course, with better quality data, with better quality, new cost customers in your direct business is also important. That is what customers today require. And last but not least, also in the B2C, I know the most of us are not directly in the B2C, but even if you do or support with better quality, saving resources, that is also in the B2C communication important, I would say. Harder to find the right figures, but it is an issue. So how can we do that? We talked about the C, so detection is the most important. Only if we find deviations, if we find the defects, we can work with this data. So that is the most important. And in the last years, we focused very much on improving our inspection systems to be more precise, be better in the detection. Afterwards, we can classify. So what we do is we use from different channels, different defects. We can classify that to a process step. Decoy snippers, for example, if you have pressed in that, if you have that, you can go back and you know exactly what to do. Or here, heat stripes, for example, go back and reduce the parameter to flatten the paper, for example. That is an MFC example what we have here. So what we do here is classify the defects we found, classify and sort it to a certain process step you have in your production. And with this information, you can give you can hand over a recipe to your people to avoid them. Of course, you have the possibility to create all the defects in a special way, and we have also a tool to analyze that, and I will come back to that later. So that are the tools we have. If you have the data, what else can you do with that? Let me talk about optimization. So if you have now the causes of a defect, and you know where that deviation or this defect lead, which cost does that lead? What optimization possibilities do you have? We have here an analysis tool. We call it QLive. You can even with each system, or if you have only one system, you have that tool. What I'm talking about that right now, you can have an analysis tool to give you the right answer based on the data we generated with the scanners. You can implement also complete the inspections of your line. You know that you get the complete line information. you can integrate all the systems from Baumer to generate the data, so you have the complete information from your, let's say, production site. Or we have customers, if you are on a group level, you can also summarize all quality data from, let's say, from your complete group, from all your production sites, generate that, and yeah, and now work with this data, you know, help each other train. So I already mentioned you have different uses of the quality data. That could be a supervisor of an system, maintenance. It could be hotline, the quality manager, the plant manager, or the user will be work with this data. Of course, with this you get a perfect overview of your current production as well as your production in the past, and you know exactly what happened, you know. And I will shortly explain what are the usage of the information, how get you an overview to your production or to your site. Here we have, for example, an example on different places. You have the line number 1, 2, 3, and different productions. You get at least with your on your client computer or on your tablet, you get at least the status: are your systems running? You know, for example, do you have a production right now? Why do you have no production, and maybe you expect to produce? And you can have also access from your client, maybe from your office, to see what is going on a certain machine. You can directly integrate or open the user interface and see what happened, instead running through your complete production and go to the machine. So you don't need to be in front of the machine. You can do it from wherever you want. You can generate based on the QLive also very powerful reporting. And what reporting mean? What are the information you get? I will come to this point. Okay, you can network your systems. You know, you can control that. In regard to the QLive, we did already a webinar that is available. You can also see that we recorded that. So I will be here very on the surface of QLive because of the functionality of QLive, because that is what you can see if you be interested in that other webinar. So I just will mention that on a high level base. Okay, so once again, let's come to optimization and to the point, what can we do with the information we generated? You know, how can I read that? Here we have a situation. As you can see, we produce here on a short cycle press, 3,800 plates are produced, and here we have first choice and first choice marked. Though that is okay, but we have a reject rate of 4.6%, much too high. So how can we reduce that, and what do you have? What is needed to do? That is the question. How can you reduce 4.6%? If you have, therefore, you need the right information. It's here Dekorschnipsel, that is in German. That is in, let's call it is, I would say in English, it isn't pressed in. You know, it's a snip of paper pressed in, and that was on the 27th A year ago, it was a big issue, and on the 28th, it was also a big issue. So you have to focus mainly on these decor particles to reduce your 4.6 percent rejection rate. That is what we have to do. So now, now make out of data, make information. You know, how can you realize the potential of the generated data? Data is, from my point of view, is important, but nothing. Generate information out of that. Let me use this example we had right now. Here is a possibility. You can select two different interfaces to different selections analysis tools. Here we have the time. We are interested from 27th to 29th, and we see we have this 4.6% of rejection rate. This represents, let's say, 76%. If you focus only to the 3 items, don't worry about what happened here. Focus on these 3 items. If you could reduce that or eliminate these reasons for rejects, you can come up from 4.6 to 1% of rejection rate. It's not 0, but it's much better. So that is what I'm not sure, your service or the production manager or the user of your line has to do. Focus on this information and correct it immediately. So we have, beside we call it facts and figures, beside of that, we have another very impressive, and as soon as you are trained, a really good tool, because humans are vision driven, so the red window on this small defect picture give you the signal that is in reject. The yellow is, we call it second choice or maybe first choice, but marked means you have to look especially. This is right now it is good, but your process is driving into the direction of the reject. So you have to focus on these here if you react immediately and change the process and turn the process to be more tolerant, then you can avoid that these lead also to reject. What you see is some pictures, and I picked out. Even if you see, for example, here these images, you may know what that is already. In this case, that are the first on the first 2 plates, we see this oil drops, and after a while it is the same drops, but not that bright. So therefore we know exactly what happened here. It's an oil drop. And here the next example, we have here paper snips, so that are pressed ins, and we know exactly if you lay down the paper, there is the reason for these pressed ins, and to avoid them, you know exactly where to go to and give your user the information, and he can correct it immediately. So that is the in addition to the facts and figures, you have these images to react immediately to control your complete production process. Okay, predictive quality means here we have this we have an effective comparison of two production lines. That is also extremely helpful. You know, if you have on one line the right parameters, the right settings, how can you bring that to the next line? How can you bring that even to another site, to another country? It is also possible with that tool, you know, to have really the seamless quality over your production site, over your complete, let's say, on a group level. That is very important. Okay, let me summarize what I see predictive quality. How can you control predictive quality with automated optical inspection systems? It is objective in the quality evaluation, no human factors. You have an immediately process control, as I mentioned before. You know, give your user the right recipe to react, or even look into your quality data and correct it. Sometimes in lot size number one, you have, if you produce very seldom for example, a decor, how can you otherwise get the right information? With these systems, you have really a fast return of investment, because if you correct it in the right way and correct it immediately, you avoid a lot of the costs. And the costs, as I mentioned before, are not only the reject, there are much more cost factors you have in such a modern production. We have, of course, a flexible connectivity. It is possible to use data from ERP, use data from your PLC MES system, integrate that, have standard protocols developed. We worked a lot on the fast installation and easy to maintain. Our systems are right now pre-configured. We do have implemented an FAT process here internally to do a pre-configuration of the systems before we install them on site. And last but not least, it's a relatively ease of use and the intuitive user interface. So it works more or less like you know it already from your mobile, and that is what we implemented here also. Though touchscreen surface, that's the way we do. Okay, you can always contact me as well as my colleague. It's Detlef Schröder. He's the product manager here internally. If you have any question, don't hesitate to contact him. He will forward that to our sales representatives in your country, and feel free to contact him. We have a next webinar planned end of July, maybe our beginning of August, where we we'll talk about tips and tricks with our systems. You know, what can you do? What are maybe others doing to use them right? Thanks a lot for your interest. I'm very open to answer now your questions. If anything open, feel free. Thank you.
Thanks, Stefan. So now we can go to the Q&A. Let's start. Do you have customers who already use data generated by Baumer for process improvements?
Yes, that is good. So I would say the users we have, which are worked, for example, with QLive, they use this extremely intensive. We have that on a single machine base, but also on a group level, where we can generate a one-page report where you see exactly what is for example, the reject rates of all production sites. We have that where you can go directly and use it immediately to control, see what happened yesterday to avoid to avoid the, let's call it, failures or the process deviations from yesterday to avoid it today. So that is on different level. We have a lot of customers which are really happy to use that. You have to train yourself a bit to understand and work with them. But if you worked with a QLive, I guarantee I never had a customer who switched it off when he knew how he can use, or how he can, let's call it that way, how he can generate out of the data the right information for his job. So that is very often used.
Okay. I'd like to hear more about panel edge sensors. Who should I contact?
Please contact Detlef Schröder. He will. It is dependent on where are you located. Then he will give that to the salesperson, and he will forward that, and you will immediately get the feedback from our sales rep. Please contact Detlef Schröder.
Can you share results from QLive analysis just to make clear what kind of information you have?
We can, yes. I recommend also contact Mr. Schröder. We have a webinar where we go very in depth of QLive. That is roughly Christoph Schmidt gave this speech, and it's roughly a 20 to 30 minute, and that answer the complete questions in regard to QLive, and there you we go in the depth of what information you can get. But the information is in regard of the process. When did you produce what? About timing. About, you can select it to different defect types. You can also, you have a huge in the QLive. It's predefined more or less what you can see. But I recommend go to this webinar and you get it in detail, or we can organize a direct meeting with you to explain it and go directly to your questions you have in regard to QLive.
Do you offer support of the implementation?
Of course, we have a service team, so it's in different way. We have a service team installing our systems. We have now here two people in our service team. They are on the hotline. They support even if after the implementation, if you get the questions, it's a 24/7. You can reach them exactly when you are producing. So it's they are available. They are two on the hotline. Also, our engineers can link to that, and of course, our service technicians give you a training. And often we have a situation where we also do a retraining after a certain time to explain, and they use, the best way is have a training and do a retraining after a certain time if your questions rise up, and then you know exactly how to work with the systems.
Thank you. How can Baumer scanners help making my life as production manager easier?
Okay. Yeah, that is the first step is how can you digitize your production process? That is what our scanners are doing. Then you have generated data. So if we see deviations, if we see, I call it deviations, not only not only a defect. If you see a deviation in your production process, then you know anything happen. And now with QLife, you can ask your question. What is your specific question to your process, and then you get in the information what happened. So data is the one. The other thing is get the right informations to make the right decisions. Focus on what is the most important. That make it easier. With my example, you had to do only three. If you focus on three defect types, you reduce your reject rate from 4.6 to 1.1. That is a possibility to decide and decide information based, and after you can decide in the right way to focus on the most important.
The device can scan one surface or two surfaces of board at the same time.
So always the bottom and the top, the right and the left side. So it can scan two sides of the board at the same time.
Is the QLife program is cloud-based, or it is running any server or any computer?
It is right now running on a SQL server. Server is typically located at your site, so you have the control of the server. So it is a server-based SQL server-based solution.
For board edge detection, you use different device?
Yes. So that depends very much on your production. For example, if you have a foiling process, that is typically we use different devices than if you have a edge banding process. We have to control if we have to control lacquering on an edge of a flooring product, then is a different in terms of that. So that really depends on what is your process, what is your target, and based on that we have different solutions to have the right system running for your production.
Okay. Is the QLife is creating automatic warnings to the actual running production?
Yes. So it is up to you. You can select and you can do the settings. When do you want to have a warning, and when do you want to have a reject, and when do you want to get only a message, So that is you can pre-select that and set it based on your quality handbook and based on your requirements. So that is relatively easy. That's at 2 clicks to set it up. If you get from if we have, for example, if you need, let's say, not with the first event, not with the first, let's say, first dot on a board, you don't need an feedback. But if you have it often, let's say 5 times or 10 times, then you would like to get a warning. That is what you can select, set it up in your system, and then it is relevant for this product.
Mm-hmm. QLife is also usable for the raw board production, e.g. after sanding lines.
Yes, that is also so the robots, we have a robot system, and I mentioned each and every system we have is able to link the information into the QLive. So then you can really match all information together. And that is a big advantage, if you have if you are a customer starting from board production until short cycle presses and edge bending, you can put all your systems into the QLive database and work with this data and generate the right information. Yeah? Also for flooring, for example. So all our systems are connectable to the QLive.
Okay. Have you got already feedback about improvements of the production after a certain time of using the inspection systems?
Yes. Unfortunately, we cannot disclose that, but we know we have customers. The important thing is they could drive their production into quality production. So it's not. How can I say that right? So quality production is have the right yield, the right the same output as normal, but with an very high quality standard. If you see and can classify a defect and could react immediately, go back in your process and correct it. And most of the time, you as customer know exactly what to do. If you get the knowledge, okay, that is a defect, you know most of the time, the experts know the most of the time what to do, and then you can change it immediately. So we have customers, they could reduce the reject rate and improve the quality. And improve the quality means your customer come back to you and say to you, wow, you are better qualified in terms of our internal quality process. And that is what we have from many of our customers, where they said, okay, it was possible, even with the same, we could produce the same with a higher level of quality.
Okay, perfect. So now we are finished with the questions. Thank you for being here. We wish you a nice day and see you soon for the next webinar. Thank you, Stefan, for your presentation.
Thank you so much for your interest, and feel free, don't hesitate to contact us, and feel free to ask your questions if they rise up afterwards. Thank you so much. Bye bye.
Thank you. Bye.